Intro music. Picture this scenario for a second.
Right. You are halfway through fixing a complex coding project. You are finally getting some really useful results.
The underlying logic is starting to click into place.
And then, suddenly, you hit the Claude Token Limit. Everything just grinds to a complete immediate halt.
Exactly. You are forced to wait for the reset. It breaks your flow state entirely.
Yeah, while other developers are shipping code, you are stuck. You are just staring blankly at an error message.
Welcome to today's deep dive. We are exploring a detailed guide on the Claude Token Limit.
We are going to unpack the hidden drains on your usage. We will explore how to accurately diagnose them.
We will also cover the quick, everyday fixes you need. And then we'll get into some really advanced setups.
Our mission today is very specific for you. We aren't just trying to make you buy a higher plan.
Throwing money at this issue won't fix the root cause. We really want to fix your working habits instead.
Because paying for a higher tier just gives a longer runway. It doesn't actually fix your underlying project settings.
Let's start with the most fundamental issue here. It is the hidden drain. Why do developers hit this invisible wall?
The biggest misconception is about your current prompt. People assume a short, 5-word prompt costs almost nothing.
But large language models are completely stateless by design. Claude doesn't actually remember anything from 3 minutes ago.
Right, and that means it rereads your project instructions. It rereads every single file you already loaded.
It has to process everything from scratch, every single time you hit enter.
It is the ever-growing context window. As the context size increases, token usage scales up exponentially.
The AI recalculates relationships between every single word, beat. It is basically like carrying a massive backpack on a hike.
That is a perfect analogy.
Every new step requires significantly more energy. This happens because of the accumulated weight of the past conversation.
You are dragging a mountain of old, irrelevant data. Maybe you pasted in 500 lines of server logs.
You fixed the bug already, but those 500 lines are still sitting in the backpack.
The context just continues to bloat after every request. You might be loading way too much from your local environment.
Things like your CLAUDE.md file take up huge space. Because of all this invisible weight, the window gets choked out.
We all fall into that trap eventually. We want this omniscient coding partner that remembers everything forever.
2-sec silence. I still wrestle with prompt drift myself, throwing too much into one session without thinking.
It is just so incredibly easy to do. But you have to actively check what is hogging your tokens.
If all this invisible weight is dragging us down, how do we actually see what's in the backpack?
You use specific diagnostic commands to peek inside the context window.
Let's talk about diagnosing that problem then. How do we systematically check what is eating our limit?
The guides outline 2 very specific diagnostic commands. You should always run these before changing your coding environment.
The very first one is the usage command, right? In the app, you simply type /usage.
Yeah, and it is much more detailed than a percentage. It shows your overall plan limit and your current usage.
But crucially, it shows your session activity over time. This helps you identify the macro pattern of your work.
Meaning you can tell if it was a long work session, or if you hit a sudden, massive usage spike.
Exactly. It tells you whether you're running a marathon, or if you are just sprinting into a brick wall.
You don't want to change your architecture for one bad query. You first note the overarching pattern.
Then you dig deeper with the second command, which brings us to the context command.
It is the most revealing tool you have. You just enter /context.
This shows precisely how much of your window is filled, and it provides a granular breakdown of those tokens.
It isolates tokens from your messages and your system prompt. It also breaks down active skills and your MCP tools.
Let's pause there for a second. What exactly are MCP tools in this environment?
Connections that let AI read your local computer files directly.
Got it. So things like connecting to your local Postgres database. The context command breaks all of that down.
Right. And it highlights those massive files Claude already read. It exposes all the old, stale information holding you back.
Now, when you see a massive usage number, it's tempting. My first instinct is to wipe the slate entirely clean.
It is a terrible idea to just nuke the session.
You really have to be surgical about your approach here.
Yeah.
You need to identify the main source of the waste first.
You fix only the biggest source of bloat. You do this so you don't lose the useful project settings.
The core problem might just be a long conversation history. Or it could be one massive log file from earlier.
If you blindly delete everything, you break your workflow. You lose the nuanced context that helps the code compile.
Once we've identified the biggest context hog, what's the immediate triage step?
We ruthlessly prune the conversation and environment without losing the core task.
Let's move into those quick everyday fixes then. How do we effectively clear, compact, and clean up our workspace?
The absolute simplest method is just clearing the context entirely. When you switch to an unrelated task, open a new chat.
That makes total sense for a hard pivot. If I move to front-end CSS, Claude doesn't need database history.
Exactly. It completely prevents old tokens from bleeding into new requests. Alternatively, you can use the clear command in your terminal.
But obviously, sometimes you are still grinding on the same task. The context just becomes wildly bloated over several hours.
This is where the compact command comes into play. It is arguably the most powerful everyday tool for a developer.
You use the compact command with very specific instructions. You have to tell Claude exactly what to retain.
There's a great example of this in the materials. You ask it to keep all important architectural decisions.
You explicitly tell it to remember the bugs found. You also tell it to outline the immediate next steps.
Claude then processes the entire bloated history. It summarizes the conversation based on your strict criteria.
The documentation mentioned one instance where this was huge. It saved 35,000 tokens in one go.
35,000. That is a staggering amount of invisible weight removed.
It is massive. But I have to push back a little. Isn't it slightly risky to let AI summarize its own context?
It is a completely valid fear. What if it compacts away a critical edge case bug?
Exactly. You might lose the one detail you actually needed.
But the safety net lies in the instruction itself. By giving clear, explicit boundaries, you control the narrative.
You are providing a strict engineering-grade framework for the compression. You are acting as the editor-in-chief of the context.
The AI retains the vital technical details because you mandated it. Beyond pruning the active conversation, we must clean the environment.
The static elements like your CLAUDE.md file use context instantly. They load into the window before you even type anything.
You must actively remove settings that are no longer useful. Disable any MCP connections you aren't currently using.
You should also archive unnecessary workflow skills. Keep the CLAUDE.md file focused fiercely on key rules.
It should only contain the essential structure of the project. I love one specific strategy for this cleanup phase.
You essentially ask Claude to audit its own setup.
It is a brilliant, highly leveraged approach. You ask the model to review the active skills in memory.
You basically tell it to hunt for unnecessary context bloat. But the trick is, you tell it not to delete anything automatically.
Right. It simply waits for your manual approval. You ask it to show you a proposal of what to keep.
Crucially, you ask it to explain why each change helps. It audits its operating environment and presents an optimization plan.
The final quick fix to mention is model matching. You do not need the strongest model for every single task.
Choosing the appropriate model saves an unbelievable amount of usage. You hoard heavy token limits for deep reasoning tasks.
You use lighter, faster models for basic formatting or summarizing. You use them for making small syntax edits.
But you save the heavier models for truly complex work. You deploy them for architectural planning and difficult debugging.
There is a clever prompt suggested for this too. Ask Claude to review the upcoming task you are assigning.
You ask it to recommend the absolute lowest cost model capable. It evaluates the difficulty before you spend tokens to start.
What if basic pruning still isn't enough for massive, complex enterprise code bases?
We bring in heavy-duty tools to compress outputs and offload execution tasks. We will cover that right after a quick word from our sponsor. Mid-roll sponsor read placeholder.
And we are back. Let's explore these advanced efficiency setups now.
How do we fundamentally upgrade the Claude Code app experience? When basic cleanup fails, you implement structural workflow changes.
You change how Claude handles large data outputs. You change how it executes repeated, mundane workflows.
The first advanced method discussed is compressing large outputs with RTK. Now, what exactly does RTK do in this environment?
RTK is basically a format compressor. It aggressively removes extra formatting and repeated content from text.
It strips out unnecessary structural details from huge system logs. It does this before the output enters Claude's context window.
That sounds incredibly useful for processing hundreds of pages, but the documentation mentions a very crucial caveat here.
A high compression rate does not always reduce token usage.
That seems entirely counterintuitive. If the input text is smaller, it should cost fewer tokens.
You would certainly think so. But in a recent developer test, the token cost actually increased.
It increased by 7.6%, which is wild. This anomaly happened when they used a lower reasoning setting.
Wait, really? Why would a physically shorter input cost more tokens?
Because the model's attention mechanism had to work significantly harder. Large language models rely heavily on visual structure.
Things like JSON formatting or Python indentation. They use that to quickly map relationships between data points.
When compression removed all that helpful structural context, it scrambled things. The AI ended up spending a ton of internal reasoning tokens.
It spent the tokens just trying to decode the dense text. It burned more tokens thinking than it saved by reading.
That is fascinating. This means you must always test the usage command carefully. You compare the precise token results for your use case.
The next major advanced method is called context forking. This involves moving repeated work into isolated skills and scripts.
This sounds a bit like delegating tasks to a background worker. Claude Code lets you isolate a separate model for specific skills.
You set a totally separate effort level and context window. You trigger this using a specific command called context fork.
Imagine you need to parse a massive database log. A forked skill reads those huge files in an isolated window.
It processes all that heavy content in the background. Then it returns only the tiny useful result to you.
The massive raw data stays completely outside your primary session.
Whoa. Imagine scaling to 1 billion queries without ever bloating your main conversation.
It is an absolute game changer for repeated data reads. The main chat remains perfectly clean and lightweight.
Beat. You can also turn predictable steps into automated scripts. Claude focuses entirely on the high-level architecture and decisions.
The local script handles the repetitive, token-heavy actions. The final advanced method we need to touch on is Codex offloading.
This involves sending heavy execution tasks directly to the Codex plugin.
This essentially lets Claude send the blue-collar execution work away. You don't even have to leave your current terminal.
Right, there was a demo showing Codex handling code review implementation. It handled the assigned, line-by-line execution work.
Meanwhile, Claude Code retained control of the high-level planning. And the beauty is, this uses a completely separate token limit.
The clear execution tasks drain the Codex limit instead. This massively reduces the pressure on your primary token allowance.
It is true parallel processing. You divide the labor across different tools to protect your window.
How do we make these advanced habits stick instead of just reacting when we hit a wall?
We follow a strict pre-flight checklist for every coding session.
Let's synthesize the big idea here with that specific checklist. You really need to run through this to solidify the concepts.
It is a highly systematic approach to starting your work. First, you always run the usage command.
You review your current plan limits and macro token breakdown. Second, you run the context command immediately after.
You need to see exactly what is filling up your window. Third, remember to just open a brand new chat.
Do this instinctively whenever you switch to unrelated work. Fourth, deploy the compact command during those long grinding sessions.
Do this the moment the conversation history becomes too large. Fifth, manage your project setup rigorously.
Remove unused MCP connections and archive your old skills. Sixth, clean up your static instructions constantly.
Keep the CLAUDE.md file focused strictly on core rules. Seventh, manage the AI's responses actively.
Ask Claude Code for highly concise answers whenever possible. Eighth, always match the model to the task at hand.
Use a lighter, faster model for simple administrative work. Ninth, manage your repeated workflows with clear automation.
Turn predictable rules into isolated automated scripts. And 10th, offload the heavy execution away from Claude.
Send suitable tasks to Codex when both products are available. And finally, always check usage and context again.
You have to do this after making any structural change. You need to empirically verify that your optimization actually worked.
Speed. The real big idea here is a fundamental shift in perspective. Taming the token limit is not about writing shorter prompts.
It is entirely about environmental context management. It is about controlling the invisible weight you force the AI to carry.
When you ruthlessly control the environment, prompts take care of themselves. You stay in your flow state for much longer.
You finally stop constantly watching that limit bar creeping up. Think about your own workflow today for a second.
Yeah, how much of your own mental token limit is being drained?
You carry around unnecessary context from previous unrelated tasks constantly. We carry invisible weight from emails, messages, and abandoned side projects.
Maybe we all need a mental compact command to clear our heads.
We definitely do. Thank you for joining us on this deep dive. Otiro Music.